Hi there. In this video, we're going to discuss, basically look at a simple reaction. N2 plus H2 gives NH3. And what we're given is 5 grams of each of the reactants. And we have to find out the limiting reactant and the theoretical yield. Now, while we'll do that, we'll also show you how to calculate the percentage yield if the actual yield is given. Okay? So let's get right into it. So the first thing we need to do is check if the reaction that's given to us is balanced or not. In this particular case, it's actually not balanced because, as you can see, there's 2 hydrogens out here and 3 out there, and then there's 2 nitrogens out here and only 1 out there. Okay, so let's go ahead and balance it. So we're just going to put a 3 out here and a 2 out there. And now you can see we have 2 nitrogens out here, 2 out there. And we have 3 times 2 is 6 hydrogens, and then 2 times 3 is 6 hydrogens. So we have the same amount of nitrogens and the same amount of hydrogens on both sides of the equation. So this equation is balanced. Next step. Now we got to go in to try to calculate the limiting reactant and then the theoretical yield. So what we have to do is we have to work with what's given to us. We have given 5 grams of each of the reactants. So the first thing we want to do is we want to convert the grams into moles. Okay, so to convert the grams into moles, we have to use this formula. I'm going to just write it up here. To go from grams to moles, we have to divide by the molar mass, which means we need to find the molar mass. So to find the molar mass, we're going to look at the periodic table. And if you actually look at the periodic table and calculate it for nitrogen, that is actually 28.02 grams per mole. And for hydrogen, it is 2.02 grams per mole. And while you're calculating the molar mass, you'll also need the molar mass of the product. So the molar mass of NH3 is 17.04 grams per mole. And just a quick side note out here, to calculate the molar masses, all you have to do is look at the periodic table. So let's say, for example, we're calculating for NH3. We look at the periodic table, look for nitrogen, that's going to be 14.007. And then look for hydrogen, that's going to be 1.008 or 1.0074, depending upon the periodic table you're looking at. And then you multiply that 1.00 something number with 3. And add that to the 14.00 something number, and that gives you the 17.04. That's how you calculate the molar mass. So once we have the molar mass is calculated, we're going to use this formula out here to calculate the moles, okay? So all we have to do is take this grams and we're going to divide it by the molar mass. So when we divide that by the molar mass, we get 0.1784 for this. That is going to be moles. And then we're going to do the same thing out here. That's going to give us 2.475 moles. Okay, so now we have the moles of this and the moles of that. Okay, so now we have to look at the balanced equation and take a look at what's happening out here in terms of moles. If you just look at the equation by itself, you can see that 1 mole, so I'm going to put a 1 out here, we can see that 1 mole of N2 gives us 2 moles of NH3. And if we look at the hydrogen, we said 3 moles of hydrogen can give us 2 moles of NH3. So that's the ratio, okay? So if we had 1 mole of N2, then we would have gotten 2 moles of NH3, okay? And if we had 3 moles of H2, we would have gotten 2 moles of NH3. So what we have to do is, with these number of moles of N2 that we calculated from the 5 grams, we have to use this ratio to calculate how much NH3 is going to be produced if we have these number of moles. To do that, we just take this and we convert this, make this into a conversion factor, okay? So we put what we're trying to find out, which is the moles of NH3, that goes on top, and what we are starting with, that goes below, okay? So if we take this moles and we multiply it with 2 NH3 over 1 N2, so notice carefully, we put the 2 NH3 on top and we put the 1 N2 below, okay? And out here, if you put the N2 and you put moles out here and moles out here, notice carefully, everything will cancel out with the exception of moles NH3, which is exactly what we're trying to find out. And now what this gives us is 0.3568 moles NH3. So what we have out here, if we try to understand what just happened, is if we started off with 0.784 moles of N2, we would get 0.3568 moles of NH3. Now let's try to do the same calculation for the hydrogen, okay? So if we start off with, notice carefully, we divided the 5 grams of hydrogen by the molar mass, and that gave us 2.475. So we'll start off with 2.475. I'll just write that down here, 2.475 moles hydrogen, and we'll make this ratio into a conversion factor. So 2NH3 goes on top and 3H2 goes below. So times 2NH3 over 3H2. And of course, we can add them all out here if you want, or you could put that out here, right in here, if you want to be technically correct. But what really matters is to be able to set this up in such a way so that we are only ending up with NH3 at the end, okay? So these two, if we cancel out the units, those two go away. And then if we crunch these numbers, we get 1.65 moles NH3. So now, once we've calculated how much NH3 would be formed if we started off with these many moles N2 versus these many moles H2, the NH3 that is formed in the lesser amount, which actually happens to be this one, that is going to tell us the limiting reactant. So basically what we're saying is that we're limited in the production of the NH3 by the amount of nitrogen we have, okay? And so in this particular scenario where we're given 5 grams of each, the 5 grams of nitrogen is going to be the limiting reactant. So nitrogen is going to be the limiting reactant, okay? That's how you calculate limiting reactants. It's always going to be the one with the lesser, that's going to produce the least amount of product. Okay, so to calculate theoretical yield, all we have to do is we need to first understand that a particular formula, okay? And the formula is, how do you go from moles to grams? Because theoretical yield, we got to calculate it in grams, okay? So to calculate in grams, we have everything out here in moles. We got to go from moles back to grams, okay? So to do that, we just draw an arrow this way and we just multiply with the molar mass. That's how you go from moles to grams, okay? So to calculate the theoretical yield, number one is we're going to work with this, not with this, by the way, not with this, because that's too much, okay? We're going to work with this. So what we're saying is that if we used up all the 5 grams of reagent, we'd produce 0.3568 moles NH3. So the theoretical yield of NH3 should be 0.3568 moles NH3 times the molar mass of NH3, which is 17.04 grams per mole. And if we calculate that, we're going to get 28.116 grams. This is the theoretical yield, all right? So that is my theoretical yield of ammonia. And what that really means is that if we started off with 5 grams of N2 and 5 grams of H2, then we will get a maximum of 28.116 grams of NH3, the product, okay? Now, here's a question. What's going to happen if, when we do all this and we go with the maximum amount of product, well, are we going to have anything left, okay? Yes, we are, because now the hydrogen, notice carefully, in order to produce, we went from 0.1784 moles to this many moles of NH3, but if we used up all the hydrogen, we would get way more NH3. We did not use up all the hydrogen, okay? So how much hydrogen was actually used up, okay? That's number one. And number two is there some going to be left over? So we can just visually first look at this and say, well, since hydrogen produced too much NH3, that hydrogen is going to be the excess. my excess reactant. So oftentimes you'll come across questions that's going to ask you which one is the limiting and which one is the excess reactant. Well, this one is the limiting reactant, and then that's the excess reactant. And then the question might say, well, how much excess? So, well, to calculate how much excess, all you have to do is compare the nitrogen to the hydrogen ratio, okay? So we're going to just do that out here. So if we start off with 0.1784 moles into, how much hydrogen is that going to use up? So we're going to make a similar ratio out here, 3 hydrogens to 1 nitrogen. So that's times 3, I'm going to just write this properly, 3 moles hydrogen over 1 mole nitrogen. And that's going to give us 0.5352 moles hydrogen. Okay, those two cancel out. Okay, as you can clearly see, there's way less hydrogen that's been used up than what we calculated based on what was given to us, because we calculated these many moles, and as you can see, we barely needed that. Okay, and then we can go deeper from that, but that's all we need to know right now. There's like way excess, we only needed that much. Okay, all right, so now the last part of this is to figure out the actual yields, okay, and then the percentage yields. All right, so let's talk about actual yields. So for actual yields, once the reaction takes place, now this is all theoretical. Everything that's happening out here is on a whiteboard. So that's theoretical. Which means that this is an ideal scenario. The reality is, if you do this reaction in a lab, there's many factors like human error. You may have spilled something, sometimes the reaction produces their side products. Sometimes the reaction doesn't go to completion, okay? For many reasons, you're not really going to end up getting 28.116 grams. You're going to end up getting something that's lesser. Okay, so let's say you actually got, so that's my actual yield, is 15.75 grams of NH3. All right? So now what we're going to do is we can calculate the percentage yield, okay? So the percentage yield is going to be equal to your actual yield divided by theoretical yield. Actual yield divided by theoretical yield times 100, okay? So if you do that out here, that ends up being 15.75 grams divided by the 28.116 grams times 100. And that gives us 56.0%. And there you have it. We basically found out the percentage yield. As you can see, that percentage is a little over 50%. So there's a lot other stuff going on in the reaction, which is totally fine in the real world. Most of the time, the reactions don't go to completion for many reasons. Sometimes you spill things, human error can happen. Okay, but that's basically how you kind of in summary calculate the limiting reactant. From there, you calculate the theoretical yield. You can figure out the excess reactant. Okay, and then finally, if the actual yield is given to you, how you can go about calculating the percentage yield using this formula. All right, I hope that made sense. I hope you learned something about reactions. This concept should actually, or rather this methodology should actually put you in a good position to solve about 90% of reactions that you see, of questions that you see involving these terms and these concepts. Thank you for watching.